Back. Problem 3. Julia wants to determine a 98% confidence interval for the true proportion of times she rolls a 1 using a fair six-sided die. How many rolls must Julia make to get a margin of error less than or equal to 0.05? To find n, use the guessed value p star 1 over 6 for the sample proportion and the values for z star from a z table or a t table. Round to the smallest integer that works. Okay, so here you want to estimate n. All right, so how do you find sample size n? Well, for estimating p, if you have a preliminary estimate for p, then that's the formula. If you do not have a preliminary estimate for p, then that's the formula. Whichever formula you use, if n is not a whole number, increase n to the next higher whole number. After you do that, increase the sample size n to ensure both n times p is greater than 5 and n times q is greater than 5. So you need to check these two happen also. Okay, so in our case we have a preliminary estimate, so we are going to use the first formula with that as your p. Okay, now you need z sub c. What is z sub c? It is critical value. Okay, critical value for the desired confidence level. So commonly valued you use from your table here. All right, so where is my table? There is my table. All right, so z value, that's the table that I'm going to use. So we need the following work done. All right, we need this particular formula. N equals, it is p 1 minus p parenthesis, it's a fraction, z sub c over capital E the whole power 2. This is the formula we are aiming for. Okay, capital E, mind you, is the maximum error allowed, which is 0.5. So in our story, let me write down all the ingredients for our problem. Okay, P is 1 over 6. Okay, they are telling us to use this as an estimate. E is 0.05. Sorry, margin of error less than or equal to. So this is the maximum that you're allowed. And you want to find Z sub C for 98%. So C is 98%, which is 0.98. So let's bring in our table. 0.98. The critical value Z sub C is 2.33. All right, so that's 2.33 is Z sub C. Okay, so now let me calculate this using our calculator. If I can find it, there you go. Okay, so P times 1 minus P times parentheses ZC 2.33 over E 0.05 close parentheses power 2. That is n with a decimal. Okay, so you get a decimal, so you're going to increase it to the next. So you're going to increase it to the next whole number. So that is 302. Now, let me remind you, you need to check. So it's not enough to stop there. You need to check that n times p is greater than 5, n times q is greater than 5. So you're going to take that 302 times p, that is 1 over 6. Is it greater than 5? Yes. What about n times q? Remember q, it's always q is 1 minus p. All right. So instead of p, I will now have 1 minus p. That's also greater than 5. So this n is good enough. So that's 302. Whoops. Round to the smallest integer, that works. Okay, so that is actually incorrect. You need 302 because this 0.6 some odd has to be updated to the next whole number. So regardless, as you saw, it wouldn't accept 302, so I tried 301. So try either one. Theoretically, you need to go one up. Okay, so this completes problem 3. Go to next problem. This is a long problem, so we will start this one on our next video. Until then, bye.